Fibonacci series with integral calculus. Okay, so we are pursuing discussion in Fibonacci series with integral calculus. Fibonacci series is a series which is a kind of wonder in mathematics. Very different kind of series, and generally it is called fx is equal to fx minus 1 plus fx minus 2. If I have a series of numbers, if I have a series of numbers like 0, 1, 1, 2, 3, 5, 8, 13, 21, 21, 34, 55, and so on. Then in series, people would have seen many series in their life, many series. The simplest one is the number 1, 2, 3, 4, 5, 6. Alternate series is 1, minus 2, 3, minus 4, 5, minus 6, 7, minus 8, and so on. This is alternate number. Anyway, there is one more number, that is Fibonacci series. In series, there are two things. One thing is the position number, and one thing is the number. If I say I have a series of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, then at position number 5, the number is 5. At position number 10, number is 10. At position number 15, number is 15. At position number 25, number is 25. If I talk about Fibonacci series, then at position 0, number is 0. At position 1, number is 1. Position 2, number is 2. Position number 3, number is 2. 0, 1, 1, 2. Position number 4, number is 3. Position number 5, number is 5, and so on. What is the position number? If I have a series of numbers, what is the position number and what is the number there? These are the two things. What is the position number and what is the number of there? Fibonacci series, I have given an example of how Fibonacci series came into the picture. Is considered an amoeba. An amoeba, when it is born, then after 2 days it divide it into two, where one is mother amoeba and another is child amoeba. Mother amoeba, then it start dividing into two every day, and child amoeba, after 2 days, then every day it keeps on dividing in two. Make sense? Okay, it is like that. If I am bringing a child amoeba on day number 1, then it is 1. Day number 2, it is 2. Day number 3, it will become double. So day number 3, it is 2. Day number 4, then only mother can have another one. So it is 3. Day number 5, now mother and children on the day number 3 are ready to make 2. So it will become 3. It will become 3 plus 2. That is that is 5. Day number 6, 3 are ready to divide it into. Then it will become 5 plus 3, 8, and so on. Mathematicians took it in different way. Mathematicians said that if you consider any day, okay, if I take any day, then the previous day, whatever the amoeba are, they are retained on the next day. If I am talking about x day, any x day, then x minus 1 day, whatever the number of amoeba are there, same amoeba are continuing on x day. Same. Okay, why it is happening like so? Because amoeba are not dying. Once they start dividing, they will keep on dividing. Yes, as per this fundamental. This is the one thing. Second thing is that if I'm talking about x day, then x minus 1 day, the number of amoeba are there. I can call it function over x minus 1. If x minus 1 is the day number, then function over x minus 1 will give the number of amoeba on that day. So function over x minus 1 will become function over x. Function over x equal to function over x minus 1. Same code. Okay, but someone would say on the x day, whatever there is x minus 1 day, they will continue to come on x day. That is true. But on x day, few amoeba will divide into 2 also. How many amoeba will divide into 2? So this is day number x. This is day number x minus 1. So whoever born on x minus 1 day number, they will not get divided into day number x. Only the amoeba who got born 1 day before or before, they will only divide on day number x, because it takes 2 days time to start the division. Makes sense? So if it is x minus 2 day, x minus 1 day, x day. On x day, whatever number of amoeba are on x minus 1 day, they will continue to the x day. And whatever there in amoeba x minus 2 day, all amoeba will now multiply. They will divide into 2. Means the x day amoeba count is amoeba count on x minus 1 day plus amoeba count on x minus 2 day, because whatever there is x minus 2 day, after 2 day they will become twice. So fx equal to fx minus 1 plus fx minus 2. Makes sense? This is Fibonacci series. This is typically a Fibonacci series. We have seen three computation on Fibonacci series. Addition of all the odd day, day number 1, day number 3, day number 5, day number 7. If I compute the addition of all days, then how much it will come? Addition of all the even days, then how much it will come? Okay, addition of alternate series. Alternate series means, consider the first day it is 1, next day it is 1 again, next day it is 2, next day it is 3, next day it is 5. Now day number is 1, 2, 3, 4, 5, 6, 7, 8. On the when day is even means day number 2, day number 4, day number 6, day number 8, day number 10, and so on. If day number are even, then the amoeba count is negative. Consider something like that. Okay, they are dancing in reverse direction whatsoever. So in the even day count, there on the even day count, then the count of amoeba is considered as negative. This is called alternate series. Means 1 minus 1, 2 minus 3, 5 minus 8. Okay, then 13 minus 21, like so. We have seen addition of that also. Let's talk about the full addition now. Full addition means amoeba on day number 1, amoeba on day number 2, amoeba on day number 3, amoeba on day number 4, amoeba on day number n. How many amoeba are there on day number n? No, this is not what we want. We want addition of all the day. On the day number 1, 1 amoeba, day number 2, 1 amoeba, day number 3, 1 amoeba. Then total it is day number 3, 2 amoeba. Then total it is 4. In 4, in 3 days, total amoeba is 4. Someone would say it is not 4. It is what you see in day number 3. But consider this kind of summation. I want, if I say function over day number 1, or I can denote it as u1, u bottom right 1, means on day number 1 how many amoeba are there, and that is u1. Okay, if it is u1, then u1, u2, u3, u4, and un. Means day number 1, 2, 3, 4, how many amoeba are there? What I want is u1 plus u2 plus u3 plus un. What is the total summation of amoeba up to un? Someone can try in simple manner also. What is simple manner is? I believe u1 equal to u2 minus u0. u1 equal to u2 minus u0. u2 equal to u3 minus u2. Makes sense? Well, u2 equal to u3 minus u1. Makes sense? u1, the amoeba count on day number 1, equal to amoeba count on day number 2 minus day number 0. Because day number 2 is addition of u1 and u0. Makes sense? So I can say u1 equal to u2 minus u0. u2 equal to u3 minus, I'll try again, u1 equal to u2 minus u0. u2 equal to u3 minus u1, u3 equal to u4 minus u2. Makes sense? I shall write in a row manner like that. Un minus 1 equal to un minus un minus 2. Un equal to un plus 1 minus un minus n plus 1 minus un minus 1. If I add these two, u1 equal to u2 minus u0, u2 equal to u3 minus u1. There is a problem. Okay. u1 equal to u2 minus u0. Okay. u1 equal to u2 minus u0. u2 equal to u3 minus u1. No, this will not give the result what we want. We'll try another way. u1 equal to u1 equal to I'm confused. Okay, that's why I try integral calculus. Okay, this way I don't know what it will be. There are this is the way we tried for the even number and odd number summation. u1 equal to u2 minus u0. Okay, this is what I remember we tried. Now there is a different way. If I want to calculate this, I don't remember. Okay, I'm trying, but I'm not because way are different now. And now let's try integral calculus to compute the summation. Let's try integral calculus, what it comes. Okay, if I try integral calculus to calculate the summation, now for integral calculus at any position x on the xth day, how many amoeba are there? That is phi 1 to the power x minus phi 2 to the power x divided by square root of 5. This is what is that. We will see that also how we deduce this formula, that on day number x, the number of amoeba on that day is phi 1 to the power x minus phi 2 to the power x by square root of 5, where phi 1 is a magic number and that is a square root of 5 plus 1 by 2, and phi 2 or 1 plus a square root of 5 by 2. Phi 2 is 1 minus a square root of 5 by 2. Phi 1 is always positive, where phi 2 is always negative. So phi 1 to the power x minus phi 2 to the power x by square root of 5 is the number of amoeba count on day number x. Okay, if that is the case, then if x is even number, because phi 2 is negative, 1 minus the square root of 5 by 2 is negative. So when x is even, 1 minus the square root of 5 by 2 is same as minus square root of 5 minus 1 by 2 to the power x. If x is even number, then full term will be positive. Outside negative is waiting. It will become phi 1 to the power x minus whatever we calculated to the power x by square root of 5. If x is odd number, then minus square root of 5 minus 1 by 2 will be negative. Minus is waiting outside, it will become positive. So we will rephrase this as square root of 5 plus 1 by 2, that is phi 1 equal to a, and a square root of 5 minus square root of 5 minus 1 by 2 is b, that is nothing but minus phi 2. Phi 2 is 1 minus the square root of 5 by 2. Minus phi 2 is the square root of 5 minus 1 by 2. I call it b. So I can say that for even days, when days are even, second day, fourth day, sixth day, how many amoeba are there? Then a to the power x minus b to the power x by square root of 5, where b is square root of 5 minus 1 by 2, that is positive. A is the square root of 5 plus 1 by 2, that is positive. On the odd days, day number 1, 3, 5, 7 and so on the odd days, it is a to the power x plus b to the power x by a square root of 5, where a is a square root of 5 plus 1 by 2 and b is a square root of 5 minus 1 by 2. Okay, both are different. One is a to the power x minus b to the power x by 2. One is a to the power x plus b to the power x by square root of 5. That is also by square root of 5, if I said something else. Anyway, let's divide this problem into two sections. One is odd number of days, day number 1, 3, 5, 7. One is even number of days. Here on a particular day, x is odd number. Then formula number of amoeba on that day is a to the power x plus b to the power x by a square root of 5. If day count is even, then on the x day it is on x day it is a to the power x minus b to the power x by a square root of 5. Understandable? Let's calculate the summation for the odd number. Then calculate the summation for even number, and we will merge it, and we will try to come up to a solution. Okay, so we will do so. We will try to come to a solution and we will do so. So we will use as usual, that is successive approximation fundamental. That is our concept in doing the summation and series. Successive approximation. What is successive approximation? So quickly I will talk about it. Successive approximation is a concept where I have x-axis. This is x-axis. If this is x-axis, then this is x equal to 0, 1, 2, 3, 4, 5, 6, and so on. Okay, now x talks about the day number. X represent the day number 0, day number 1, day number 2, day number 3, day number 4, 5, and so on. When day number is 1, day number 2, day number 3, when days are in odd number, day number 1, day number 3, day number 5, then at that time number of amoeba, which is y-axis, this is x-axis, then function over x or y-axis is the count of amoeba on that day. So day number 1, day number 3, day number x, the amoeba count is a to the power x plus b to the power x by a square root of 5. Okay, in that manner, now if I if I touch all the top point, then it will become a function, and that is function over x. Function over x is a discrete function, and which is defined at x equal to 1, 3, 5, and so on. And it is a to the power x plus b to the power x by a square root of 5. I can think about another function called gx, and gx is a continuous function, means x equal to 1 and x equal to 3. There is an area strip, it goes and hit gx. Gx dx limit x equal to 1 to 3 give this area strip, and that will be exactly same as function over x at x equal to 1. Means for each function over x at x equal to 1, 3, 5, n, on right hand side I have an area strip that goes hit the gx. This is the concept of successive approximation. Means if I say summation x equal to 1 to n fx, that is same as fx plus fx plus fx plus fx plus fx, that is fx at x equal to 1, fx at x equal to 3, fx at x equal to 5, and so on, fx at x equal to n. If someone says that you cannot go like 2 jumping, you have to jump 1 then someone can think about different formula of fx. But if I jump 2, then fx is a to the power x plus b to the power x by a square root of 5. Means that is same as equal to limit x equal to 1 to 3 gx dx plus limit x equal to 3 to 5 gx dx plus limit n to n plus 1 gx dx. So for each fx, I have gx dx. If I calculate this full integration, I get the full summation. So if I talk about any x equal to x, then fx, that is like this, is a to the power x plus b to the power x by a square root of 5. It is same as if I talk in gx, then area from x to x plus 2 gx dx. This area is same as fx at x equal to x. Means fx at x equal to x equal to limit x equal to x plus 2 gx dx. Through this concept, I have to find gx. Fx is a to the power x plus b to the power x by a square root of 5. For time being, kick out the square root of 5. I don't need it. Okay, then a to the power x plus b to the power x equal to limit x to x plus 2 gx dx. What gx I'll take so that it will be exactly as a to the power x plus b to the power x. We have done in the past many times. Gx will come, we will start gx, I can start gx. If fx is like this, a to the power x plus b to the power x, fx equal to gx dx, gx equal to dfx by dx, means dx equal to log a to the power x plus log b to the power x. If I integrate, it will become a to the power x plus b to the power x. Very nice. But I have to set limit x to x plus 2. If I set limit like so, a to the power x plus 2, a to the power x plus 2 minus a to the power x plus b to the power x plus 2 minus b to the power x. Okay, it will become a square minus 1 bracket a to the power x. If I take out a to the power x, a to the power x in bracket a square minus 1 plus b to the power x b square minus 1. Okay, this is how it is. If it happens in that manner, then we are getting extra a to a square minus 1 b square minus 1. So we will take gx as log a by a square minus 1, a to the power x plus log b by b square minus 1, b to the power x. Okay, if I do so, like that, then integration with dx, limit x to x plus 2 will become a to the power x plus b to the power x. This is what we want. Means gx we have identified as a to the power x into log a by a square minus 1 plus b to the power x into log b by b square minus 1. Now the full addition of, if I want, then begin is x equal to 1 and end is n plus 2, where n is odd number, because last area is n to n plus 2. First area is 1 to 3. So 1 to n plus 2 integration will give the full summation of all the odd numbers. Okay, now how much it will come? So log a by a square minus 1, a to the power x plus log b by b square minus 1, b to the power x. Makes sense? Okay, integration log a and log b will go up, a to the power x by a square minus 1 plus b to the power x by b square minus 1. Limit is 1 to n plus 1, n plus 2, a to the power n plus 2 minus a to the power 1 by a square minus 1. A is square root of 5 plus 1 by 2. A square minus 1 will again become a square root of 5 plus 1 by 2. Anyone can compute. So a square minus 1 is a. B square minus 1 will come as minus b. Numerator is a to the power n plus 2 minus a. I can take out. It becomes a to the power n plus 1 minus 1. But denominator, numerator, they cut each other, cancel each other, nullify each other. It becomes a to the power n plus 1 minus 1 plus minus, because minus b will make it minus b to the power n plus 1 plus 1, a to the power n plus 1 minus 1 plus b to the minus b to the power n plus 1 plus 1. Minus 1 plus 1 will cut each other, and it will become a to the power n plus 1 minus b to the power n plus 1, where n is odd number. So if n is odd number, then a to the power n plus 1 minus b to the power n plus 1, n plus 1 is even number. If people remember, on the even day count, even if x is even number, then on x day count, number of amoeba is a to the power x minus b to the power x by square root of 5. Right now, by a square root of 5, we are not taking into the picture. A to the power x minus b to the power x. Here we have a to the power n plus 1 minus b to the power n plus 1, where n plus 1 is even number, where n is odd number. Means this is nothing but amoeba number on n plus 1th day, where n is odd number. Makes sense? Okay, in that manner, I can say un plus 1. U means number of amoeba on day number n plus 1. So the summation of all odd number amoeba is nothing but up to n, where n is odd number, it is un plus 1, a to the power n plus 1 minus b to the power n plus 1. Let's try for the even number days. If I calculate for even number day, it starts from day number 2 and day number 4, day number 6, day number n, where n is even. Dx will be same thing. Log a by a square minus 1, a to the power x minus, here it will be minus log b by b square minus 1 b to the power x. Now we have to integrate it and set limit from 2 to n plus 2, where n is even number. If I do like so, then how much it will become? If I integrate, then log a log b will go away. A to the power x by a square minus 1 minus b to the power x by b square minus 1. Limit is 2 to n plus 2. Limit is 2 to n plus 2. A to the power n plus 2 minus a square. A to the power n plus 2 minus a square by a square minus 1. A I can take out. A to the power n plus 1 minus a. B square minus 1 is minus b. Minus b minus it will make positive. Okay, b cut down. So it will become a to the power n plus 1 minus a plus b to the power n plus 1 minus a minus b. So for the even number summation, it is a to the power n plus 1 plus b to the power n plus 1 minus a minus b or minus a plus b. That is a to the power 1 plus b to the power 1. On day number 1, that day number is odd, the number of amoeba on that day is a to the power 1 plus b to the power 1 only, and that is 1. Anyone can compute. A is the square root of 5 plus 1 by 2, b the square root of 5 minus 1 by 2. Okay, then they will cut each other. It will become 2 square root of 5 by 2. Square root of 5 by square root of 5, it is hidden. We have not taken. It will become 1 only. So now we have a to the power n plus 1 plus b to the power n plus 1 minus 1, where n is even number. Make sense? Now if I add both odd and even both together, if I add both together, then it will become a to the power n minus 1 minus b to the power n minus 1 plus a to the power n plus 1 minus b to the power n plus 1. This is for odd days. For even days, a to the power n plus 1 plus b to the power n plus 1 minus 1. So net is a to the power n plus 1 minus b to the power n plus 1. A to the power n plus 1 plus b to the power n plus 1 minus y minus 1. Here n is even number, n is odd number. Let's take that the last day we are calculating addition of all the day up to n day, where n is even. If n is even, then in the odd series, n will go back. I have to subtract n because odd number last day will be n minus 1. So a to the power n plus 1 minus a to the power n plus 1 will become a to the power n minus a to the power n. Makes sense? Where n is even number, where n is even number, where n is even number, a to the power n minus b to the power n, and where n is even number. If n is even number, this is the number of amoeba on nth day. Number of amoeba on nth day. So it is un. Un. We are calculating summation up to n day, where n is even number. Then first term of the odd will become a to the power n minus b to the power n, where n is even number, and it is perfect for the unth day. So un will be replaced by un plus a to the power n plus 1 plus b to the power n plus 1. N plus 1 is odd. If n is even, it is odd. That is nothing but un plus 1, because n plus 1 is odd number. So it becomes un plus 1 minus 1. Un plus 1 is un plus 2. So addition of all the Fibonacci series up to n number, where n is even number, then it will be un plus 2 minus 1. Let's take n as odd number. Then even number will be 1 less than that. So it will be transformed as a to the power n plus 1 minus b to the power n plus 1, where n is odd. Even will be 1 less than that. A to the power n plus 1 plus b to the power n plus 1 will become a to the power n plus b to the power n minus 1, where n is odd number. So if n is odd number, a to the power n plus 1 minus b to the power n plus 1, n plus 1 is even, and minus is there perfect for un plus 1. So it is un plus 1 plus a to the power n plus b to the power n, where n is odd number, plus it is perfect for un, same thing, un plus 1 plus un minus 1, un plus 2 minus 1, means summation of all the Fibonacci series up to nth day, full summation. If I add full 1 plus 1 plus 2 plus 3 plus 5 plus 8 plus up to nth day, then it will be un plus 2 on n plus second day. How much amoeba is there? Minus 1. That will be summation up to n. This is through integral calculus. Okay, I don't know how someone can proceed in normal way. Use integral calculus. Same formula for every possible summation and series. Amazing, mind blowing. Okay, we will file some kind of paper on this, or we'll try to do something, probably protecting it also or whatsoever. Anyway, this is not available in any of the book. Okay, please don't mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 in the India country code 9483160610 is the telephone number. Okay.